All right, guys, number 2 says determine an equation for the linear function g of x equals 5x minus 7, both after a reflection in the x-axis and y-axis. So they want us to do both. So I'm going to go ahead and split my paper here. And we'll do the x-axis on this side. And we'll do the y-axis on this side. Okay, so remember that if you're reflecting over the x-axis, remember that you're changing y. And that if you reflect in the y-axis, you're changing x. Okay, and so remember that in order to change y, remember y is f of x. In order to change it, we put the negative in front. Okay, when we are reflecting over the y-axis and we change x, remember that it's f of x, but we're going to squeeze the negative in with the x in order to change the x. Okay. All right, so I know that this one's called g of x, not f of x, but you get the idea. Okay, so we're going to go ahead and say that negative g of x is equal to negative in front of the whole g of x function is going to look something like that. Okay, and so we're going to go ahead and say negative g of x is equal to negative 5x plus 7 when we distribute that negative. Okay, so remember for the x-axis, we got to distribute that negative. Okay? In our other one, we're going to go ahead and say that g of x, but technically it's going to be g of negative x, since we're changing x to do a reflection in the y-axis, is equal to, anytime you see an x, it comes out and gets replaced with a negative x. So 5x becomes 5 times negative x, and then minus 7. Okay? And so g of negative x, we're just going to clean it up. 5 times negative x is negative 5x, and then minus 7. And there's our reflection in the y-axis. Okay? Number 3, it says if a quadratic function has the equation, determine the equation of y equals negative f of x. Okay? So again, that negative is really in front of y. And so what you are to think is that they're changing y. And if you change y, that this is a reflection over the, what we're doing, we changed y. Change y means reflection over the x-axis. Okay, so they asked what transformation does that represent? So that question's answered, but we didn't answer the question yet about what the equation is. So again, when we put that negative in front of the whole thing, we have to make sure we use parentheses. So we're going to go ahead and say negative f of x is equal to negative, and then in parentheses, 2x squared minus 3x plus 8. And all we're going to do is distribute this negative. Okay, and so we're going to end up with y equals, or we can keep it as negative f of x, I guess it doesn't matter, equals negative 2x squared plus 3x minus 8. Okay. All right, next one. Number 4, it says consider the function g of x equals what 2 transformations have occurred to the graph of y equals x squared to produce the graph of g in correct order. Okay, so what happens is that this is our parent function. So you can see a couple things have changed. This is one of them, and this is the other. If you take those 2 circled items out, you're left with y equals x squared. Okay, so the negative and the plus 4 are the 2 transformations that have occurred to it, but they want to know what they are. Okay, so if we start with y equals x squared, and we turn it into y equals negative x squared, okay, they're basically, well, you have to think, are you replacing the x with a negative x? Because if you did, then it would still be positive x squared like we saw in the front. Okay, so if they're not, they're putting the negative in front of the whole x squared. And we know that that is something that we actually just did in the 2 questions above it. Okay, and so really this little middleman step is they're doing y equals, the negative is going here in front of x squared, and that's how they're getting this. Okay, and so if they're putting the negative in front of the whole thing, they're changing the y, which is a reflection over the x-axis. So it's a reflection over x-axis. Okay. All right. After they do that, then they're tacking on this little plus 4. So then we go into y equals negative x squared plus 4. And notice that plus 4 is not being grouped with the x. Therefore, it's going to affect the y. And it's a shift up 4. So shift up 4 units. Okay. All right. So then number 5, it says if f of x has a vertex at 4, negative 8, and g of x equals, then what is the vertex of g of x? Ooh, okay, so we got a bunch going on in here. We have the negative, we have the plus 1, and we have the minus 7. Okay, so remember, anytime it's grouped with x, that has to be talked about first. So that's going to be our very first transformation we talk about. So that plus 1, we saw that on day 1, that's a shift. We would think to the right one, but it's actually to the left one. Okay, and remember that's going to affect our x. Okay, then we go from left to right. So now we're going to talk about the negative out in front. And since it's not grouped with the x, it's changing the y. And we just talked that when you change the y, it's a reflection over the x-axis, just like we saw in the last 3 questions. So this is a reflection over x-axis. But because it's a reflection over the x-axis, remember that it's going to affect the y-coordinates. Okay. And then the third one, all the way to the right-hand side there, you see that minus 7. And so we're back to being a shift. And that is down 7 units. Because you're going down, that's going to affect the y. Okay. So you guys can see that the only things that affect the x are the things that grouped with the x. The only thing that was grouped with the x was the 1. Okay. And all the other ones are going to affect the y. So if we have a turning point or a vertex at 4, negative 8, if we shift left 1 unit, we're going to go ahead and subtract 1 from our x. And so now our vertex will be at 3, negative 8. Okay. All right. When you reflect over the x, you change the y. And when you change the y, you just change it to the opposite sign. So this 3 is going to stay, but that negative 8 is going to become a positive 8. Check. Okay. Down 7 units means to subtract 7 from the y coordinate. So when we subtract 7, we're going to end up at 3, 1, and that is our final vertex. Okay. And so that is our answer. Okay. All right. Number 6. It says if f of x has a domain of negative 5 to 2 and a range of 6 to 11, determine the domain and the range of h of x if h of x is equal to. Okay, so we got a couple things in here. We have the negative with the x and the plus 4. So only 2 transformations are occurring to this. Okay, so the very first one has to be talked about is within the parentheses. You see that negative, you're changing the x, which means it's a reflection over the y-axis. Okay. So I'm changing the x as a reflection over the y-axis. Okay, but remember, you're changing the x, so that's going to affect the x. Okay, and then you see that plus 4 at the end, which we know that's a shift up 4 units. And that's going to not be grouped with x, therefore it's affecting the y. Okay, all right, so here we go. Because we have domain and range, we have to realize that the domain is both x values. Okay, so we're going to do the same thing to both numbers in the domain. And so our new domain, we're going to get by reflecting over the y-axis, which is just changing the x. So you're going to change your x from a negative 5 to a positive 5. And you're going to change your 2 from a positive 2 to a negative 2. Okay? However, there's a problem with our domain that when we do that, it's no longer the small number first and the larger number last. So we're going to cross that out and we're going to rewrite it as negative 2, 5. Okay. Our range goes from 6 to 11, and we're going to shift it up 4. So everybody gets shifted up 4 units, okay, which means all we're going to do is add a 4 and add a 4. Since those are both y values, they're both going up 4. So 6 up 4 becomes a 10, and 11 up 4 becomes a 15. Okay, and we're going to go ahead and put our square brackets back around them, and there is our domain and range. Okay. All right, last question here, number 7. It says the graph of function f of x is shown below on 2 grids. Okay. Part A on the bottom here says graph and label. All right, so we're going to graph and label negative f of x. So here we go. So we just have to realize, what is that negative doing? Okay, so remember that that is really y. So that really means a change in y. If you change y, this is a reflection in the x-axis. Okay, so all we're going to do is reflect this over the x-axis. So remember, this is our x-axis. And remember a little bit from geometry, okay? So if this is 3 units below, we're going to go ahead and go 3 units above. Okay, 1, 2, 3. Same thing with this point over here. It's also 3 units below, so it's going to flip over and be 3 units above. Okay? All the other points that are above have to flip down and go below. So this one's 2 units above. This will be 2 units below. Same thing with this one. Okay. These ones up here are 1, 2, 3, 4, 5 units to the line. So 1, 2, 3, 4, 5 units over. Okay. Same thing with that one. And that one right in the middle, the turning point or the vertex is 6 units above. So it's going to go 6 units below. And there it is. We graphed. Okay. All right. And what they said to label too. So we're going to go ahead and say negative f of x. All right, in this next part, part B, it's asking us to graph and label f of negative x. So see that negative in there? It's on the x, so they're changing x. If they change x, it's a reflection over the y-axis. So we're going to go ahead and reflect over the y-axis this time. Okay, so our y-axis is vertical. And so we're going to reflect each point over that line. All right. Let's start with this one on the right-hand side. He's only 1 unit to the line, so he'll be 1 unit over. Okay. This point here is actually on the line of reflection, so he stays. Okay. All the other points are on the left-hand side, so they're going to flip and be on the right-hand side. So I'm going to start with this point up here. He's only 1 unit away, so I'm going to flip him over. Okay. This one at the top, our turning point is 2 units, so he'll be 2 units on the other side. Okay. This point here is 1, 2, 3 units, so 1, 2, 3 units. This point here is 1, 2, 3, 4, so 1, 2, 3, 4. And this last one here is 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5. And a nice smooth curve. And there is our reflection of our parabola over the y-axis. Okay. Oh, we got to label them, so it'll say f of negative x. All right, hopefully that makes sense, and I will see you guys for tomorrow's lesson. We will be in Unit 5 doing day 1. Okay. All right. Bye, guys.